In order to add rational expressions with unlike denominators, we need to find the least common denominator. So if I have 2p and 8p, how could I make 2p look like 8p? Well, we could find the least common denominator. Make a little table. In order to be divisible by 2p, you need a factor of 2 and a factor of p. In order to be divisible by 8p, you need a factor of 2, p, and then 2 more 2's because of 8. So least common denominator in this case is 2 times p times 2 times 2, which is just 8p. And you might have already seen that. Okay, if I take 5 over 2p times 4 over 4, that's going to give me 20 over 8p plus 3 over 8p. So my final answer is 23 over 8p. And I can't simplify that any further. Next, if I have 6 over x minus 5 over x minus 3, the least common denominator, because each of these is prime, is going to be x times x minus 3. So on the left, I'm going to multiply by x minus 3 over x minus 3. That's going to give me 6 times x minus 3 over x times x minus 3. On the right, I'm going to multiply by x over x. Remember, harnessing the power of 1. That's going to give me 5x over x times x minus 3. So now I have 6 times x minus 3 minus 5x all over our common denominator of x times x minus 3. Well, I need to go ahead and simplify this numerator. So I get 6x minus 18 minus 5x. That's going to give me x minus 18 over x times x minus 3. And I can't simplify this any further. I could go ahead and distribute the bottom, but that's not entirely necessary unless it asks you to in the homework to fully simplify. On an exam, it'd be okay to leave it like this with me. So if I have 1 over q minus 1 minus 1 over q plus 1, I can go ahead and multiply my fraction on the left by q plus 1 over q plus 1. And I can multiply my fraction on the right by q minus 1 over q minus 1. That's going to give me q plus 1 minus q minus 1 over q plus 1 times q minus 1. So if I have q plus 1 minus q plus 1, that's going to give me a numerator of 2. So I have 2 over q plus 1, q minus 1, or I could FOIL that out to q squared minus 1 squared. For example 2, I have y over y minus 2, and I'm going to rewrite this so my variable is first. So I have negative y plus 2 over 8. But remember, we don't like negative leading coefficients, so I'm going to have y over y minus 2 plus 8 over negative y minus 2. So these denominators are not the same, but I could go ahead and distribute this denominator up to my numerator. So I've got y over y minus 2 minus 8 over y minus 2. Now they have the same denominator, so now I have y minus 8 over y minus 2 as my final answer. So this one wasn't so much finding the least common denominator, but manipulating my denominator to look the same. Now things get a little more complicated. So I've got x minus 3 over x minus 2 plus 5 over x minus 6 over x squared minus 2x. Well, let's go ahead and factor that denominator under 6. That gives me x times x minus 2. which was going to be the least common denominator, right? If I've got an x and an x minus 2, that'd be our least common denominator, which maybe I should write down. So I'm going to multiply this first equation by x, this second equation by x minus 2 over x minus 2. So I have 3x plus 5 times x minus 2 minus 6 all over x times x minus 2. And man, I need to simplify that numerator. So I have 3x plus 5x minus 10 minus 6, that over x times x minus 2. Let's go down another level. That means I have 8x minus 16 over x times x minus 2. I can go ahead and pull out a factor of 8. That gives me 8 times x minus 2 over x times x minus 2. Go ahead and divide those. I have 8 over x as my final answer, fully simplified. Next, if I have m plus 4 over m squared minus 2m minus 3 minus 2m minus 3 over m squared minus 5m plus 6, the first thing I need to do is I need to go ahead and simplify those denominators. I don't mean simplify, I mean factor. So I think, okay, what are the factors of AC that add up to B? Well, the factors of negative 3 that add up to negative 2 are going to be negative 3 and 1. And then I think, okay, what are the factors of AC, which is 6, that add up to negative 5? That's going to be negative 2 and negative 3. So if I look at what all these have in common, they have an m minus 3, but I also need an m plus 1 and an m minus 2. So I'm going to go ahead and multiply this equation on the left by m minus 2. You can kind of see that. And this equation on the right by m plus 1. That's going to give me m minus 2 times m plus 4 minus 2m minus 3 times m plus 1 all over m minus 3, m plus 2, m plus 1. I need to go ahead and simplify that numerator. So m minus 2 times m plus 4 gives me m squared plus 2m minus 8 minus, and I'm putting all this in parentheses, I've got 2m squared plus 2m minus 3m minus 3 over our denominator. So I've got m squared plus 2m minus 8 minus 2m squared. 2m minus 3m is a negative m, minus is a plus m, plus 3. So I have all of that over m minus 3, m plus 2, m plus 1. And now I need to combine my like terms. So let's move over here in green. So I have m squared minus 2m squared gives me a negative m squared. 2m and m gives me a positive 3m. And negative 8 and 3 gives me a negative 5. All over m minus 3, m plus 2, m plus 1. Well, I don't like negative leading coefficients, so I'm going to go ahead and factor that out. So I have negative m squared minus 3m plus 5 all over my denominator. And I think, okay, can I factor my numerator? Are there any factors of AC, which is 5, that add up to 3? The answer is no. So my rational expression is fully simplified.